All right, guys, we've learned addition, property of equality. We did subtraction, property of equality, and we found that to solve the equation, to solve the variable, we kind of did what you guys called the opposite property. So here we see 3 times x. We don't know what x is. It's a variable. We don't know what it is. But what we do know is there are 3 of them. So the way we model that is to get 3 variables. There's 1, 2, 3 x's, or 3 variables. So there's 1, 2, 3 variables, or 3 times x. And we know that it's equal to 9, but the question is, if we go back down to our model, if all 3 of them are equal to 9, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. We can't really see an order to this. So try to think of like playing cards. Okay, if you're all playing cards, you got 3 people playing cards. Okay, if we know that all 3 of them have 9 total, well, let's try to distribute them just like you would with the card game. You don't give everyone their cards all at once. You distribute it evenly, or measure the numbers out evenly. It's called measurement division. So let's hand out those 9. Okay, let's hand out those 9 cards. So there's 1. He gets 1. And she gets 1. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we've distributed all 9. So if you do this in your head, if you think, okay, we're working with friendly numbers, you can really solve this in your head. 3 times the number equals 9. If you know your basic facts, you know that it should be 3. 3 times 3 is 9. But the question is, when you model it, is your answer reasonable? Okay, we're working with friendly numbers, so we can check, okay, x is 3. If you look at just one of them, you have truly divided it into 3 groups. And one of those x's is equal to 3. 2 of the x's would be equal to 6. And all 3 would be equal to 9. Okay, the other way of doing it is the algorithm, or what I call using the line of equality. So we treat this like a surgical, did I get it wrong? We treat it like a perfectly balanced equation. I keep saying that this is surgically balanced. My pen's a little off. So whatever I do to this side, I must do to the other. So what is the opposite function of multiply? Well, the opposite is divide. Well, when you're solving equations, you don't use a division symbol like you used to. You just use a fraction. Look, so 3 times x, what's the opposite of multiply by 3? You divide by 3. And you know that with the line of equality. What you do to the left, you must do to the right, or 9 divided by 3 as well. So on the left side, they cancel each other out because 3 divided by 3 is 1. So 3x divided by 3 groups, just like we did down here, is equal to a single x. And we keep our equal sign lined up. And 9 divided into 3 groups, well, we did that down here. You'll notice that we have the 9 groups divided into 3. And your answer is 3. So the modeling of it and the algorithm are equally important. The same thing goes with 3 times the number is 12. Well, in your head, we're working with friendly numbers. You know that 3 times 4 is 12, so x equals 4. But to model it, it's going to help you solve problems when the numbers aren't so easy. So before you say, I don't have to do that, I can do it in my head. Well, keep in mind you should. We're still working with friendly numbers. Okay, if you look at this right now, these 12, they're not really divided into 3 equal groups. If you divide 3 x's into 1, 2, 3 groups, well, you need to do the same thing to the other side. So if you really want to solve it, you divide those 12 constants into 1, 2, 3 separate groups, giving you the solution. X, or the green bar, is equal to 4. This is your solution. So there's 2 ways of doing this. We have the algorithm and we have the modeling. The algorithm Just remember your remember your properties. First mistake of the year. Okay, remember your properties. Right now we're multiplying. The opposite of that is division. What you do to the left, you must do to the right. Use your line to separate. 12 divided by 3 is 4. You find that your two answers match. And that is how we roll.